that function as it's written would be in what form that we learned about earlier? Intercept, very good. So that's an intercept form. So if we're gonna write that into, can't find them out, there it is. If we're gonna write that into standard form, come on, turn the page. There we go. So x minus 1 and x minus 6. Alright, so we'd start here, take the x times x, that gets me an x squared. The x times negative 6 is negative 6x. Now I'm going to take the negative 1 to everything. So negative 1 times x is negative 1x, and negative 1 times negative 6 is a positive 6. Now I said earlier in the year, 90% of the time when you multiply those, you'll have like terms in the middle. So I'm going to combine those. Negative 6x minus 1x gives me negative 7x, and then I still got a plus 6. So we got most of it done. What is still left is the negative 4. So I'm just going to drop negative 4 down to the party and then distribute it to everything. So that'll be easy work on that. So I'm going to drop my negative 4 down. So I got negative 4 times x squared. Y'all didn't know we got to bomb things in math, did you? Negative 4 times negative 7x. And negative 4 times 6. And put my f of x. And that's it. So, there was a reason I chose this to get us started today. We went from intercept form, multiplied it out, and got to standard form. What we're going to do today is the other way. We're going to start with standard form. If I said this, so we went intercept form, multiplied, got to standard. So we're going to go standard form, unmultiply, which is kind of like division, and get to intercept form. It's actually, when you break something down, it's factoring. So we're going to factor these things today. What we're getting to, because we've looked at the graphs for, we've been in school a week and a half, we've been looking at the graphs of parabolas for a week and a half, so we're fixing to start learning how to solve them. And one of the easiest ways to solve a parabola, is by factoring. So that's what we're going to start practicing. You, Miss Lamb says y'all did factoring in Algebra 1, and I believe her, but I don't think y'all do enough of it. Because every year my Algebra 2 students struggle with it. They've seen it before, but they struggle with it. So we'll review it. It'll look familiar to you, but we got to practice it a lot. All right, so there's a quadratic. That's in standard form, x squared minus 9x plus 20. And so the directions of this just say to factor. Excuse me. Now we know, I'm going to talk about B's and C's, so you know what the B and this, I'm going to talk about A's and C's. Excuse me. Fire drill got me choked up. You know what the values of the A and the C are. In this one, our A is an understood 1, right? And this one, our C is 20. So if I want to factor this, I want to break this down into what looks like intercept form. I'm going to have 2 parentheses, right? So to start the factoring off, you're going to take your A times C, and you need the factors of that add up to your B. So something plus something adds to the B. Okay, so in our case, we got a 1 times a 20. So I need to know what numbers multiply to make a positive 20. Let's just start with that. You'll be able to skip this step later on, but let's just start and list all our factors of 1 times 20. So you could have 1 times 20, right? 2 times 10, 4 times 5. And also to make a positive 20, I could also have all those same factors and both of them be negatives, couldn't I? Very good. So I need the pair of these that if I add them together, I get my B. And my B is negative 9. So 1 plus 20, that's 21. That's not negative 9. 2 plus 10, that's 12. 4 plus 5 is a positive 9. I need negative 9, right? Negative 1 plus negative 20, negative 21. Negative 2 plus negative 10, negative 12. best for last right here. -4 plus -5. Ding, 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 winner, winner, chicken dinner. So what you do when you find that pair, that's just gonna go in the back end of your binomials. Because to get an x squared, you gotta have an x times an x, right? Now you just take these with their sign. So a -4 would be -4, and -5 would be -5. And you just factored that quadratic.
Couldn't we use that like in reverse just to find the same form quick?
I don't know what you mean.
Like, I don't know either. Like, we just use those, multiply the two ends,
Mm-hmm.
and then we have our b,
Right?
and then, I don't know.
So you could use your factors to graph it quicker? Is that, yeah, I wasn't following what you're talking about. Yes, of course. Okay, now, would there be a way I could check my circled answer up there?
Plug it in the way.
Well, wouldn't it just be what I just did on the bell ringer? If I multiplied these together, shouldn't I get this? So let's just do, you don't gotta write this down, let's just mentally check it. X times x is x squared. Here I got a -5x and a -4x. Does that make -9x? Yeah. And then -4 times -5, +20. So good to go on that. Okay? Y'all remember doing that a few years ago? A little bit?
Ish.
Still got a couple riders. All right. Let's look at x squared plus 3x minus 12. Now again, I don't want you to lose sight of the parabolas. We're not looking at their graphs today, but this step of learning how to factor them is important for our next step in solving them. So keep it, these are still quadratic, so they are still parabolas. We just gotta digest them a little bit different. All right, so the directions say factor. So you're gonna start with your A times C. So we got 1 times -12. So I'm looking now for two numbers that if I multiply them, I get -12, but if I add them, I get a +3. That might be a little fishy, huh? Okay, let's list them out and see. 1 times -12 would make -12. -1 times 12 would make -12. 2 times -6 would make -12. -2 times 6 would make -12. 3 times -4 would make -12. And -3 times 4 would make -12. Are there any more factors of 12 or -12? Okay, now I need them to be able to add these digits and get a +3. Well, if I add these, that's -11. That's a +11 if I add. 2 plus -6, that's -4. -2 plus 6, that's +4. 3 plus -4, that's -1. And -3 plus 4, that's 1. So do I have a pair there that would add to make 3? Nope. So that's a case where that one can't be factored. That's what it'll look like if it's not factorable.
Oh, is that like if it's above the
Very good there, Christian, very good. So, since Christian is thinking about how this is gonna play out in the future, let me show you something real fast. I wasn't gonna show this today, but you're there, so I want you to see what's going on. So what we're actually gonna be finding on these parabolas, the solutions, are the intercepts. And that makes sense, that question you asked earlier now, because that's, you were already thinking about that. So if you get one that can't be factored, that means it's not gonna have any intercepts. It's never gonna cross the axis. It could mean that, or it could mean one other thing. It could mean it's an irrational number where it crosses it. Like, that could be the negative square root of 7. It could be a number like that. So, but if it can't be factored, it'll be something weird. So good thinking on that, Mr. Christian. All right. Let's do, you needed to see one that doesn't work, so let's go back and do some more that work now. X squared minus 3x minus 18. All right, we'll go through this one together again, and then I'm gonna let you see what happens. Let you try one. So directions say factor. So we're gonna check our A times our C, and so far we're keeping it simple and making our A be 1. I designed that on purpose, keep it simple with your A 1. If you have an A other than 1, the factoring process is more complicated, so we're saving that for right now. So we got a 1 times a negative 18, so I need two numbers that when I multiply them I get negative 18, but when I add them I get negative 3. Okay, do you want me to list them all, or do you got a guess you want to try?
3.
Negative 6. 6 negative.
3 negative.
There we go.
Yeah, 3 negative.
I need my 6 to be negative because I need that, when I add them, I need the answer to be negative. So negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. Now, if you didn't know those, like Tyler and Christian were telling us there, if you didn't know them, that's not the end of the world. Just list them all out like I did on the last two. Okay? So now we're putting them in our binomials. To get an x squared, it has to be an x times an x. And it does not matter which order you put these in as long as you put them with the right sign. So the 6 has got the minus, so I gotta make sure I put that correctly. The 3 is positive, so I gotta put that correctly. So if you wanted to write it this way, that is the same thing. Because you can multiply, that's called the commutative property. Order doesn't matter on multiplication. 2 times 4 is the same as 4 times 2. Now I use this analogy a lot. The standard form, that's like your bicycle completely put together. Everything's working, watching the Tour de France right now, everything's working smooth as a bell, everything's good. You take it out on your carport and you take a piece, every single part, and lay it out on the carport. Spokes, pedals, brakes, everything, lay it out on the carport, that's your factored form. So you're taking it apart to see the pieces. So these pieces are what make up that bicycle. That's the way my brain thinks of it anyway. Weird, I guess. Alrighty. Whoops, wrong button, dummy. That's the right one. 2x. My book said R's and I changed it to X and then I got crossed up. Okay, so this one says x squared plus 2x minus 63. I want you to try to factor that. So I'm gonna be quiet and see if you can come up with the factors. what did you get when you did your A times C?
-63.
-63. Now, a lot of people are like, oh, that's such a big number, I'm not gonna be able to list all the factors. That's kinda silly, isn't it? There's not a whole lot of factors of -63, are there? I mean, I can list them real fast. 1 and -63, -1 and 63, 6 and -9, -6 and 9, isn't that all?
I mean, 7.
7, yeah, 6 and 9 is 54, silly goose. I tried to be smart and messed it up.
Fingertip.
Yeah, I've seen that. But that's all of them, if I write it correctly, and right? I mean, you can get, let's see, maybe think of one that would have a lot, maybe 64, be close to that, and have a lot more factors. So you can have them that have a lot, but just 7 and 9 and 1 and 63, not a lot to choose from. I need them to add to a +2. So that's out, that's out. This adds to a -2, that's out. Hey, what do you get when you add that? Winner, winner, chicken dinner. That's it. Now, where we're gonna go with this in the future, let me just go, well, I can just scroll this down. Where we're gonna go with this in the future is once you get those factors,
Do we need to write this down?
it wouldn't hurt. Once you get those factors, and this is what Christian was talking about earlier, that's in intercept form. So those are your intercepts. So you just set that equal to 0, each of them, and solve. And now you know where that parabola is gonna cross the x-axis. Now, you would not even have to do those steps that I just wrote out, that easy little baby math, adding the 7. You wouldn't even have to do that, because you remember from intercept form, the P and Q, remember that? They're the opposite sign. Opposite of a -7, bam. Opposite of a +9, bam. Reason you might have to do a little bit more sometimes is when we get into problems where the A is not 1, there'll be different numbers here, so you might actually have a harder equation to solve. But something that simple, once you get that, if it says solve, your next step would just be to take the opposite sign. Pretty good, pretty good, pretty good. All right. I wonder what we would do if we saw something like that. It says x² minus 49.
Is has to equal 0.
Well, we're still, yes, we're still factoring, and this still is in standard form. So what Tyler's noticed already, and probably the rest of y'all too, that this is the piece we don't have, right? So if we don't have that piece, our B would be 0. So after we do our A times C, they've got to add to 0. So let's look at that, and then we'll see if we can figure a shortcut out with it. A times C, so 1 times -49. So what multiplies to make -49 but adds to 0?
-7.
Good. -7 and 7. So, got your x and your x, and -7 and a +7. And that's it. That's you factored it, that's your answer. Now, that's a special kind of quadratic. When it's missing the B, and it's got a minus sign, what's another math word for minus that starts with a D? Difference. On the difference, don't you subtract? Okay, so we've got difference. What's special about x² and 49 that you could say with math words? So they're perfect squares, right? So it's a minus sign, difference, they're both perfect squares. This is called a difference of squares. So you could do this, and you're gonna get the right answer every time. Do your A times C and find the ones that add to 0. But if you notice that it's a minus problem, and they're both perfect squares, all you had to do was take the square roots. So the square root of x², x and x, the square root of 49, 7 and 7. One gets a minus sign, one gets a plus sign. So what if you had x² minus 81? difference of squares.
Does drawing parentheses just come with practice? Cause I can never draw parentheses good.
Well, I don't think I would win a contest for mine, so I don't know.
Math teachers always say.
My penmanship is not too good. Not too good.
I'm not always like the L.
They're either a C or a straight line.
Right.
There's no in between.
Alright, while we're on this difference of squares kick, let me ask you about this one. Could you do that the same way I just did? Okay, Christian's saying no. What's your A times C?
100.
What multiplies to make 100?
Oh, wait, yes.
No, you stick with your first answer.
Yes.
What multiplies to make 100 but adds to make 0?
Oh,
Right, I mean, you probably thinking 10 and negative 10, but 10 times negative 10 is positive 100, so that won't work. Okay, negative 10 times negative 10, that would be positive 100, but that wouldn't add to 0. That's what I meant to say earlier, right? Wouldn't add to 0. So the point of me showing you that is right there. That's what made that one different. There's no such thing as a sum of squares. So we called this one up here difference of squares because of the minus sign. There's no such thing as sum of squares when it has a plus sign. That is outlawed. That's the big no symbol over that. No sum of squares. Let me make that line go through it so it doesn't look like an underline. There we go. No
First.
sum of squares.
The first time I said no is because I forgot that you can multiply 10 times 2.
Yeah, I was just thinking of 50 and 2.
Okay, so let's look here at x squared minus 5x minus 36 is equal to 0. So this time I'm changing the question, but I'm not gonna change how we start. The question says, and this is straight out of this book, what are the roots of the equation? So roots, you might not have heard that term roots before. All roots means, it means several things, but they're all the same. It's like a big hat and all these, we could draw these out. Roots are solutions, zeros, answers, all of those things are interchangeable. So if it says find the roots, that could mean solve it, or that could mean find the zeros. And I showed you on, when I was talking to Christian, I showed you, it doesn't like my finger today, usually it likes my finger. There we go. The solutions are those places. The roots, the zeros, the solutions. When we solve a quadratic, that's what we're finding, are those intercepts. So it's possible that a quadratic has 2 roots. It's possible that a quadratic has 1 root. That one would only touch the x-axis 1 time. It's possible that a quadratic has, catch this is going to be new for us this year. It's possible that a quadratic has no real roots. What the heck does that mean? Well, we're going to learn in Algebra 2 about imaginary numbers. Now we got real numbers and we got imaginary numbers coming. So this would have imaginary solutions. It's craziness.
I'm assuming you're not meaning like a gazillion and all those.
No, they actually will have an I in them. Alright, so for the one we have there on the function x squared minus 5x minus 36, what are the roots? So throughout the next week or so, we're going to learn factoring, completing the square, quadratic formula. We're going to learn at least 3 ways to solve a quadratic. So today's way is factoring. So we've not learned the other ones yet. So if you're told to find the roots or to solve, the only way we know how today is factoring. So we've got to factor here. We've got to break down our bicycle. Okay, we'll learn more ways, but today it's factoring. After we learn them all, then it'll be up to you to decide which one's best for each case and all that type of thing. So I'm going to go ahead and put my x. Okay, now I got to find 2 numbers that when I multiply them, I get negative 36. But when I add them, I get negative 5. Is my A times C is negative 36. got 4 and 9, so I need a 4 and a negative 9, is that right? Now, I started in my head just saying them to y'all, but if you're still struggling with it, just write them all down, okay? Nothing wrong with that. So I've got a positive 4 and a negative 9. Now, you know enough from learning about intercept forms, since those x's are both 1s, but later on they won't be, but today they are, since my x's are 1s, it just makes the opposite sign. But since later on they're gonna change, I'm gonna go ahead and show my steps. So being a good habit. So you got negative 4 and positive 9. So let me erase my beautiful artwork up there, and we'll draw what this one would look like. Because once you get those zeros, if you apply that with everything that we've learned all along, you'd be able to graph that. You got a 9. You got a negative 4. It's a positive A, so it's gonna open up like how I'm drawing my mouse there. Halfway between negative 4 and 9, be 5. Would that be right? No. Let's see. Negative 4 plus 9 is 5, and then divide that by 2 for my formula. Remember that? So it'll be 2 and a half. 1, 2 and a half. There's my axis of symmetry. So that's got to be in the middle of it. So I would bet, we're not going to spend time finding the vertex today because that's what we've been doing, but I would bet the vertex would be way down here, like double digit number. Wouldn't y'all think? To make that be that wide up there on the top. That'd be pretty cool. All we would have to do is plug 2 and a half in here if we needed to find it out. But we're pretty good on that. All right. Y'all are not seeming as confused about the factoring as classes of the past. Are y'all all right with it? Remembering it pretty good? You remember it over here, Zach and Hayden? Good, good. All right, let's do, let me let you try another one. Come on there, screen. X squared plus 6x plus 5. And I want you to try to solve that. Find the roots. Think about A times C, 1 times 5. There's not a lot of choices for factors of 5. So, what multiplies to 5, make 5? That's all, the only 2 ways you can take whole numbers to multiply to get a positive 5, isn't it? So I need the pair of those that add to 6 if there is one. Well, lucky ducky, 1 plus 5 is 6. You didn't have to show this, but I'm going to try to stay in a good habit. Alright, so the one thing I would caution you about now, since we reviewed factoring and then we took it to using that to solve, I would make sure, if we have an assignment anytime coming up, that you read what the directions say. You know, you want to do that. If the directions said to factor, I would have stopped here. If it said find the roots or solve or find the zeros, I would have gone here. Okay? So factor, you're still in your parentheses, you're in your bicycle parts. Anything else, you're showing the answers. Alright. I didn't think this was going to go this fast because I thought y'all were going to not remember as good. Let me just give you one more for good measure. Is that alright? Give you a harder one this time. With more factors than 5 and 1. x squared plus 8x minus 65. And we'll set it equal to 0 and we'll solve it. Alright, 65's got a, I mean, it's a bigger number, but it doesn't have a ton of factors, but it's got more than the last problem. Anytime you're trying to find factors of a number that ends in a 5, pretty good idea to start with 5 most of the time. And 65 looks like, oh no, that's gonna have a lot of factors, but it really doesn't. You got your 1 and your 65, and then you got your 5, and wasn't that it? So what was it 5 and 13? Is that right?
Negative 5, 13.
Yes. So, here, I don't want that to look like that. So, multiplies to make negative 65 would be a negative 5 and a positive 13. And we needed that arrangement, like Tyler said, because it's got to add to a positive 8. So we needed our bigger one to be the positive. So that's how it'll look in your factors. But then when you go to solve, it flips it around, doesn't it? So you would add your 5 here. And then subtract your 13 here. Now let me say, before we shut it completely down, because we're fixing to, I wrote that in a weird order. Everything we looked at today when we started solving was set equal to 0. And it has to be, because remember on the graph, you're finding where it crosses the x-axis and that value is 0. So if it's not equal to 0, and we'll see this probably next week, if it's not equal to 0, whatever's over here, we have to make it a 0. So like if this had said plus 10, or positive 10, we would have just subtracted 10 to set it equal to 0, okay? Everybody good, understand why it's gotta be equal to 0, because that's the value on the x-axis? Fabuloso. Alright, so, I don't know, I might change my plans now, if the rest of the classes remember it as good as you, but what I planned on was tomorrow you have an assignment to practice on this, but if we don't need it that as bad as I thought we would, we might not do that. I'll have to see what the rest of the classes are like. Y'all are gonna be easy because our class is so small, so I can kind of tell if you're getting it better or not. When I got a big old group in here, sometimes it's, I don't always know. But I'll evaluate those classes and decide what's tomorrow.